Hi class. There was something in this homework that I made unintentionally harder than it really should be. Um, this is the homework, uh, I say a lot. This is the homework with the RGB LED. And in this homework, you had loops. We're using the for loop, and we use a loop inside a loop inside a loop. And the part of the homework asks, how many times does the LED color change? And if you just watch it, let's watch it while it's going through its thing. Sometimes it's changing, but um, it's hard for us to see the differences. So if you ever see like a pause, it seems like it's taking a lot longer between colors changing. There's probably a color change there that you're just not able to see. So this is again part of that thing of if this is a real RGB LED, which I've used, I think I have some around here. I might try to hook up a live breadboard so you guys can see it. It's much easier for your eye to see the differences. And so the computer is simulating it and putting some signals out there that are hard for you to see if you're just looking at that to predict how many times the color will change. This, I'm going to link to this. In the code here, I've made a lot of changes. And when you look down here, here is our, so what we have is a loop. This will go through 3 times, but each time it goes through it 3 times, it's going to go through this 3 times. And each time it goes through this 3 times, it's going to go through this 3 times. And that will be the number of times it changes the color. So probably the best way to answer this question is to mathematically think through what that would mean. How many color changes would there be? So, but I got an answer in that was really well done, except it was just the person was not able to see the color changes, so they weren't able to count accurately. What I've done in the rest of, so what you might want to do is stop this video now and go back and see if you can fix that part or try to predict that part. But then even if you can get that answer pretty easily, go ahead and come back to this part of the video because I'm going to introduce a whole bunch of new stuff when I show you how I forced it to tell me exactly the answer. Okay, so we are going to use the serial monitor. And I love this problem. I love that this problem made us go to the serial monitor because it um, it forces us to think that when you're coding in something and you say, print this, right? The code is making a choice of where to print that. Is it going to print it in this window? Is it going to print it on a web server? Is it going to print it? So the serial monitor, when you're programming with Arduino, this thing is a USB connector, right? And so when we run our code, the USB connector pops in. The USB connector in this thing is connected to our computer. As long as the Arduino is connected to our computer and we're using our computer to program the Arduino, the you can print to the computer that it's plugged into a little window called the serial monitor. Then later, if you say, well, I've programmed my little robot, but I don't want him to be stuck connected to my computer, I want him to be able to roam free, you can provide power from a battery instead, and it will continue to run the program on the Arduino over and over and over again using the power from the battery instead of having to be plugged into a computer. But as long as it's plugged into a computer, we can use our serial monitor to do some debugging. I also noticed that when I was doing this, and I was over here to press on to find the serial monitor, look right there. We mentioned that in class. There's a debugger. I have not used the Arduino debugger at all, but it does seem to be fairly nice and fairly easy to do. Okay, to use the serial monitor. In setup, remember in setup in the original one, we had to tell the pins, we had to get the pins ready, and we had to say, okay, this pin is output, this pin is output, this pin is output. When we had the button, we had to tell that the pin that the button was plugged into, you're going to be input. We also need to tell the serial window, the serial monitor that we're going to be using it. And we do that, we say serial.begin. It's like, start up serial monitor. I'm going to send you some stuff and I need you to be awake and listening. Okay? This 9600 is the speed at which the data goes across. It's it was called 9600 baud. It used to be that modems, like your only connection to the internet, was at this speed, which is pretty slow. So it's really only useful for printing out a few things. It wouldn't be a great graphics way to display things. Then to make it clear that I'm running this is because the serial monitor in this application is not clearing. I'm not really sure how to get it to clear. So what I did to make sure that I can tell the difference between each time I run this program is I have a little thing at the beginning that says serial.print. So it's going to print everything in the parentheses over in the serial monitor. Here we have some things in C. So everything inside the quotes, as we've seen before, is a string. But in C, there are some special things. Backslash says take the next character and do something special with it. So this isn't going to print \n, \n, new count starts now, ;n. It's going to print this \n in a string in C means new line. So it's going to go 3 new lines. It's like hitting the enter key 3 times. It's going to print this text and then it's going to hit the enter key 1 more time. If I don't do this at the end, then my numbers will print right after here, and I want them to print below here, so I do that at the end. Okay. The other thing I did was I created some variables up here. I declared a variable, how many times the light has changed, and I initialize it to 0. Remember, this part is the declaration, and this part is initializing it. Okay. So I come down here, and this is my old loop. I set, this was in the homework stuff before. And here's another thing. This happens a lot in different languages because a lot of times we need to count by 1. So we needed a quick way to say that. And so in C, this is how we say add 1. Add 1 to yourself. So this takes how many times the light changed, the variable that we started at 0. And this special operator +=1 says take the value that was stored in this and add 1 to it. It's the same as in Scratch when you do change by 1. I'm going to print out the value of this variable. Notice this is not in parentheses, right? Not parentheses, this is not in quotes, so it's going to print a number here. And then I'm going to print a new line to make sure that each number gets printed below the next line. Okay, and let's run it. Okay. So my light is turning off and on. And as it's turning off and on, each time it adds 1 over here. I think we're just gonna have enough time to get through this before my 10-minute video runs out. Okay, so now it's started back over. So 27 is the number of times it goes through this for loop. 27 is the number of times it goes through this for loop. When it gets all done, it goes for each 3 in this line, it does 3 in this line, and for each 3 in this line, it does 3 in this line. So that's how we get, so the answer ends up being 3 times 3 times 3. And then it loops again. All right, that's it.